Okay, so this is part 2 of our video on bearings in trigonometry. Now, up until this point, you'd probably wonder what's trigonometry got to do with any of this, because we haven't done any trigonometry, we've just done bearings. Bearings are a decent practical... that's a really annoying crow. I hope you guys can't hear that crow too much. Bearings are a really important practical application for trigonometry. So finding distances between places. So, for instance, a surveyor would use both bearings and trigonometry together quite a bit. Okay, so with these sorts of questions, you're best off drawing yourself a little diagram. So Jesse walks south for 2.8 kilometres and then west for 4.1 kilometres. So if we think of that, here's our north line. So Jesse walks south for 2.8 k's. And then he walks west. Oh, that's a horrible line. We'll have another go at that. West for 4.1 kilometres. Now we know that south and west are going to be at right angles to each other. So I'm just going to put two little dots here. That's where we started and where we finished. And what is his true bearing from his starting point to the nearest degree? So in order to find the true bearing, what we need to do is we need to think of, well, if that's our north line there, we need to find, first of all, we need to sort of draw a line between the 2 points, because that's, if we were at the start looking at the finish, that's the direction we'd be looking. And what we're interested in is this angle in and around to here. Now, importantly, we already know how to get around to south. It's 180 degrees around to south. So what we're actually interested in is if we could find out what this angle is in here, then we would be able to solve the problem, because we'd know that little small angle and we know we have to add 180 degrees to it, and that's everything we need to do. And if we think about this little angle in here, I know that this side is opposite to that angle and this side here is adjacent to that angle. So hello, I've got some distances that I know. It looks a lot like trigonometry. So which trig ratio will we use when we've got an opposite and adjacent side? TOA, tan. All right, so let's use that. So we'll say that tan theta equals the opposite over the adjacent, and in this case, the angle's the bit we don't know, so it's going to stay as theta, but the opposite we know is 4.1, and the adjacent we know is 2.8. So I can then say, well, theta, that angle that I want to know something about, is tan to the minus 1 of 4.1 over 2.8. So let's pull up our calculator here and work that out. I'll just move that over here a little bit. So shift tan 4.1 over 2.8. All right, press equals. And we've got 55.66 degrees. In this particular case, I'm just going to go to the nearest degree. So I'm going to say that's roughly approximate to 56 degrees. I'll just put 2 nearest degree. I don't know if the question actually asked. It did say the nearest degree, so there you go. So therefore, our bearing equals 180 plus 56 degrees, because we're going to use 180 degrees just to come around to south again, and then we're going to have 56 more degrees. So that's going to be 236 degrees. It did actually ask it for a true bearing, so there you go. We've got everything we need for that particular question. So yeah, if you, I would find these questions very difficult to do without drawing a picture. So I would certainly start there. Okay, our final example for this question: a ship travels south for 5 kilometres, and then on a bearing of 120 degrees for 11 kilometres. So we've got 5 kilometres south, and then on a bearing of 120 degrees. Now 120 degrees is going to be, where are we? So that's 90, so it's going to be sort of down here somewhere. And so that's 11 kilometres and this angle in here we know is 120 degrees. So we've got our starting, obviously this isn't to scale because my 5 kilometre line looks longer than my 11 kilometre line, but that gives us a basic scale. Now, the question then asks, how far east of the ship, how far east is the ship from its starting point? So if I think about that, this distance here is going to be how far east we've gone. We don't care about how far south we've gone, we only care about this distance here. So if I create a little triangle here where I run a south line and an east line, that's going to give me 90 degrees there. What I want to know is, I want to know that distance there. I'm going to call that E. That's the distance east we've gone. Now I also know that I can work out this angle in here. I'm just going to draw a little arrow over here. Angle equals 180 minus 120 degrees. All right, because it's 180 all the way around to the south, and around the south, when I made this little fake triangle up, I continued the south-north line. So this is going to be 60 degrees. So now what I've got is a situation where I have a triangle and I've got a side that's opposite to the angle I'm interested in, and I've got a side opposite to the right angle, which means it's the hypotenuse. So for part A, I could literally say that I'm the opposite in the hypotenuse. That means sine. So sine theta is the opposite over the hypotenuse. And in this case, I know the angle is 60 degrees. The opposite side is E. That's the bit I don't know. That's how far east I've gone. But the hypotenuse is 11. So I'll end up with E equals 11 sine 60 degrees. If I put that into my calculator, I'm going to end up with 9.5 kilometres to the nearest, to one decimal place. Okay, so that's our part A. So we'll go over here and with my little blue pen, I'll do part B. Okay, so for part B is how far south is the ship from its starting point. So I already know, to find out how far south, I'm interested in this part, this distance here. But I'm also got to add to it that distance there. So it's going to be 5 kilometres. I'll work this. I'll say so. It's going to be 5 kilometres because we travelled 5 kilometres south in the first place, plus distance south while going 11 kilometres at 120 degrees. So to work out that, we've got we've still got the same, we can still use the same angle, we can still use the same triangle, except now this is an adjacent side. So now I can compare my adjacent and my hypotenuse. So katoa, adjacent and hypotenuse, that's cos. So cos theta equals the adjacent over the hypotenuse. Now in this case, the angle hasn't changed, it's still 60 degrees. The adjacent side is the bit we don't know. I'm going to call that south, or S, and it's 11 kilometres long. The hypotenuse is 11 kilometres long. So we end up with the distance south that we've gone in that triangle is 11 cos 60. And so we put that into our calculator. Close our brackets and we end up with 5.5. 5.5 kilometres. So we can say therefore the distance south equals 5 kilometres plus 5.5 kilometres, because remember we did 5 kilometres south at the start, so that's going to give us 10.5 kilometres. And that's how that one's done. So once again, draw yourself a picture. It may have even paid in this particular example for me to draw a second picture for part B. You can draw as much as you want, just try and make it as clear as possible what you are working out. Make sure you know which angle you're supposed to use when we're talking about bearings. Sometimes the angle that's given, like in this case, is an angle not in the triangle that we're concerned about. and that's the end of this lesson.